Next, let's move on to Bayes' theorem. So, in the discussion of conditional probability, it is indicated that revising probabilities when new information is obtained is an important phase of probability analysis. So, meaning, dili pasabot na nakakompute na ka sa probability nimo in this period of time is dili na siya mo change, because again it is probability, it is uncertainty, so it is subject to changes. So there are events or factors that may affect in order for you to change kato imong probability computation. Now oftentimes in analyzing or in doing analysis, we often have what we call a initial or prior probability or estimates for specific events. Then, from a sample or special report or product test, we can obtain some additional information. Now, if we already have this additional information, we then update or recalculate or revise our probabilities. Thus, those revised probabilities is referred to as posterior probabilities. Now, Bayes' theorem provides a means for making these probability calculations. So, how do you arrive daw at those posterior probabilities? So, muna, it is through the use of Bayes' theorem. So, again, ato ang steps ha is we have the prior probabilities or kato imong initial probabilities, and then you gain new information which has effects on the probability on the prior probabilities, or which can cause changes to your prior probabilities. Thus, given this new information, you then apply the Bayes theorem, and once you have applied the Bayes theorem, you can then arrive at your posterior probabilities. So for us or for you to further understand this, let's ato ta dito sa example, no? So we have here, or we are given the prior probabilities. So for in this example, consider that you are a manufacturing firm which receives shipments of parts from two different suppliers. So the quality of purchased parts varies with the source of supply. So your event A1 is that refers to the part that is from your supplier, while your event A2 refers to the part that is from your supplier number 2. Now, based on past experiences, you are already given this, or you have this prior probabilities. So you have, for the probability of A, you have 0.65 or 65%. Probability of A2 is 35%. So meaning daw, based on your past experience, 65 of your materials or parts kay imong gi-purchase is gikan ni supplier 1, while 35% of your materials is gikan ni supplier 2. So mo na imuhang prior probabilities. Now, you have attained this new information. According to your historical data, the quality of ratings of the two suppliers are as follows. Si supplier 1 daw, out of the supplies nga iyang gihatag sa imuha, 98% of those are of good parts, while 2% ang bad parts. Si supplier 2 daw, out of makuha nimo sa iyaha, kay 95% is good parts, while 5% is bad parts. Now, this is already an example of your conditional, or this percentages is already your conditional probability. Nga naman, nanabi kay given, di ba? Given your supplier 1, the probability of receiving good parts is 98%. Now, given your supplier 2, the probability of receiving bad parts is 5%. So, kani siya nga data is already a conditional probability nga data. So, again, as I mentioned, given the new information, you have these new conditional probabilities. So, the first one, the probability that you will have a good part well, that you have a good part from supplier A or supplier number 1 is 98%. The probability of receiving a bad part from supplier number 1 is 2%. Now, the second one is the probability of receiving a good part from supplier 2 is 95%, and then the probability of receiving a bad part from supplier 2 is 5%. So, mo ni mohang conditional probabilities. Now, if we try to analyze it using a tree diagram, is kani siya, di ba? Imuhang product, o ay mo sa Excel, your product is, or you have your part DI comes from two suppliers, supplier 1 and supplier 2. Now, si supplier 1 is, ang imong ma-receive niya is either good part or bad part. So, you have duha na outcomes daan. Si supplier 2 is imong ma-receive niya is good part or bad part. So, in this, you already have 4 experimental outcomes. Now, if we add, or if we try to put in our, what do you call this? Katong ato mga probabilities, di ba? Kanila siya is the flow lang ni siya. If we try to put in our probabilities, inani siya ang mugawas, di ba? You have here the probability of supplier A is 65%, B is, supplier 1 is 65, supplier 2 is 35. Now, for your second step, which is the condition, so you have 98 and 2, 95 and 5. Now, the probability of your outcome, so kaning outcome, A1G, you have here the intersection of A1 and G. So, meaning, unsa ang probability nga, unsa ang katong shared points ni good parts o gikan siyang ni supplier 1. So, mo ni siya ang intersection nga good parts o gikan ni supplier 1. So, balik ta ato ang, di ba mo ni siya atong multiplication law na to, kato sa ato ang conditional probability. So, multiply the probability of A by the conditional probability of G given A1. So, you have 0.63.70 and so on and so forth. So, kani nga formula, kani ato ang formula is gikan na ni ato sa ato ang discussion on conditional probability. Mao ni siya katong imuhang, di ba? Multiplication law sa katong conditional probability nimo. So, kanina siya, mo na siya para makuha nimo ang iyang outcome. So, meaning, ang kaning 0.63.70 is now the 63.70% probability nga maka-receive ka good part from supplier A. Now, there is a 1.3% probability nga makakuha ka bad parts from supplier B. There is a 33.25% probability nga makakuha ka good parts from supplier A. And 1.75% probability nga makakuha ka bad parts from supplier B. So, ana na siya. Again, that is your intersection. Di ba? Intersection, pwede siya. Intersection points, pwede sa imuhang duha ka events. Now, you already have your prior probabilities and you already have your new information. Now, let us, or diri na mo come in atong application sa Bayes theorem. Application of the Bayes theorem in getting your posterior probability. So, to find the posterior probability that event A will occur given that event B has occurred, we simply apply Bayes theorem. So, Bayes theorem is applicable when the events for which we want to compute posterior probabilities are mutually exclusive and their union is the entire sample space. So, diha lang na siya ma-applicable ang imuhang Bayes theorem. Now, you have here kani imong posterior na or posterior computation of your posterior probability. So, ang imuha na, diba, is, kani siya is lahi ni siya sa imuhang, ingon ani ha. This is the probability of supplier 1 given na bad, or katong given the second condition. So, either good or bad part. So, muna ang sa imuhang Bayes theorem. So, giunsa na nimo siya pag arrive ani nga equation. So, we have here, sa babaw, if you can remember, di ba? this part, if ato ta balik sa atuhang conditional probability, because technically this is conditional probability, di ba kani siya conditional probability mo ni siya, di ba? Atong formula ato sa atong conditional probability is the intersection of AI and B, di ba? Mo na siya to, the intersection of AI and B. Now if mo balik ta dire, asa man to atong intersection of AI and B. So, di ba, the intersection of A and B is masolve siya through kani nga formula. The probability of A multiplied by the probability of B, A ana. So, mao na ang imuhang numerator. So, kaniha is gi-expand lang niya ang katong imuhang formula sa imuhang conditional probability. Again, kani is gi-expand lang niya ang imuhang formula sa imuhang conditional probability. Now, asa na siya mo differ? Ari na siya mo differ, igabot sa imuhang denominator. Or asa siya mas mo complicate is ari na igabot sa imuhang denominator na part. Because as you can see here, I na ang atuang A ha, I. So meaning wala pa ka, depende na siya kung pila ka buok imuhang events sa first nga step. So since duha ra man niya ang events diri, so we will only stop at 2. But if kung pila gin ang I diri, mo change mo na ang imuhang n diri So in this case, since we are only at 2, so ari ra ta kutob. The divided by the probability of your A1 times the probability of your BA1, di ba? Plus the probability of your A2 times the probability of your B given A2. So, ara lang mo stop ang imuhang Bayes theorem. So, mo na siya ang pagkuha sa imuhang, or that is how you can get your posterior probability using the Bayes theorem. So, yan na siya. Now, if ato na siyang i-substitute, ato na siyang i-substitute is ito na, 0.65 times 0.2 is 0, divided by, kato kani mga kuan, naroon ni siya sa inyuhang, katong table gani, or katong sa atong tree diagram, di ba? These datas are found sa inyuhang tree diagram na mga data. So, the probability of A is kato, 0.65 times, so on and so forth. So, you arrive at 42.62%. Now, how do you analyze that result? So, once makuha na nimo, di ba? As your analysis in the problem, we started with a probability of 65% that a part selected at random was from supplier 1. So, na 65% nga gikan daw siya ni supplier 1. However, given the information that that part is bad, the probability that the part is from supplier 1 drops to 42.62%. Kagets ra? So, ang difference ani, if imuhang question lang is the probability nga kana imuhang i-select is gikan ni supplier 1 is nara siya sa 65%. But if ang imuha nang i-take into consideration is katong mga bad na parts, again, if given nga nakay information about sa mga bad na parts, ang imuhang probability sa imuhang supplier 1 is mo drop siya to 42.62%. Now, in fact, if the part is bad, there is more than 50% chance that it came from supplier 2. So, if ang kaning formula is ilisan na nato A2, so makuha niyang amount is 57.38. So, meaning out of all the bad parts, ang gikan sa supplier 1 is probably 42.62%. Ang gikan ni supplier 2 is 57.38%. Kagets ra? So again, dinha ang ato ang gikuan is ang given na nato is the condition. Again, ang given na nato is the condition. Given that it is a good part or a bad part, unsa iyahang probability nga gikan na siya ni supplier 1 or supplier 2. Do not confuse it with your probability of kaning condition, the probability of your condition. Kani siya, ang probability of your condition is given that it is from supplier 1, unsa ang probability nga good part or bad part siya. So meaning ang kaning conditions, again, una-una ara to katok ang example sa conditional probability na kanang nana siya sa imuhang atubangan tanan. Ari sa pinakakani nga probability, ang imuhang pilianan is tanan siya kay gikan ni supplier 1. Tanang parts gikan ni supplier 1 na sa imuhang atubangan. If mo pili kag isa at random, unsa ang probability nga good part na siya or bad part imo makuha. So if mo pili kag out of all the parts ni supplier 1, if you choose one at random, there is a 98% chance nga good part na siya and a 2% chance nga bad part. Sa posterior na nato or diri sa atong i-compute sa posterior, ang naa sa imuhang atubangan is ang tanang ang condition na either good part or bad part. Mo na siya. So, ang nasa mga tubangan is, for instance, tanang mga good products. Out of all the good products, what is the probability nga inigpili ni mong isa, ang imuhang mapilian is gikan na siya ni supplier 1. Diba? What is the probability nga igpili ni mong isa, gikan na siya ni supplier 2. So, mao na ang sa imuhang posterior na probability. Now, there is another way of computing. If you don't like to follow this one, you can make use of the tabular approach. Now, sa tabular approach, is kanina na kay i-follow na mga steps to arrive at the posterior probabilities. So, first step is to prepare 3 columns. Column 1 is for the mutually exclusive events for which posterior probabilities are desired. So, unsa man to imong mutually exclusive event? Ang imuhang supplier nga event. So, you have A1 ug si A2. So, you have A1 and A2. Now, your next column daw is the prior probabilities of the event. So, pila to imong prior probability sa A1 o sa A2. So, in this case, diba, itong A1 at 2 is na siya 65%, while si A2 is taay 35%. Now, our third column daw contains the conditional probabilities of the new information given each event. Again, contains the conditional probabilities of the new information given each event. So, mo to ang katong conditional probabilities. The condition of event B given the event A. So, kato condition isa man natong i-try og kuha diri. For instance, let's try to compute na for the what do you call this? Bad part or bad part lang gyapon kay para atong i-try if ma-arrive ba gyapon ta ani nga answer. So let's try for the bad part. So balik nato sa ato ang table no. So kabaw na mo sa atong kani. So di ba na ato ang bad part ato for supplier 1 is 2%. Now for supplier 2 is 5%. Step 2 is to prepare the fourth column. Now, the fourth column is kato ng imuhang joint probabilities or kato ng imuhang intersection of your supplier o katong sa imuhang condition. Diba? Mo na siya sa imuhang step 2. Now, to compute the joint probabilities for each event, the new information be by using the multiplication law. So, meaning, multiply the prior events in column 2 by the corresponding conditional probabilities in column 3. So, ano na siya? 0.65 multiplied by 0.2. So you have 1.3%. Then for supplier 2 is 1.75%. If maka-remember mo, kana nga mga values, is nagyapon na siya ato sa ato ang tree diagram, no? Balik ta sa itong tree diagram. See? It's here. The joint probabilities is already here. 1.3% and 1.75%. So, di ba? Nanagid ni awa, yung prior probabilities is this column. During aside makitaan in the first step. The conditional probabilities can be found in this next step. Then, your joint probabilities can be found in this column. So, kana na. Now, sa posterior, is, ano siya? Step 3 is to sum the joint probabilities in column 4. So, isum daw niya to itong joint probabilities. So, we have 3.05%. Next, step 4, in column 5, so mention niya, in column 5 is, para makita na to, in column 5, compute the posterior probability using the basic relationship of conditional probability. So, mo niya nga itong basic relationship sa itong conditional probability, the intersection of events A and B divided by the intersection of, or not intersection, divided by the probability of event B. So, the joint probability of A and B are in column, itong 4. And the probability of B is the sum of column 4. Let's identify sana sum ni siya. So, again, ang imuhang joint probabilities is kanina. So, nana kay numerator. Now, your denominator is the sum of your B. Nga naman, ibabalik ato sa katong imuhang table. If mutanaw kani sa imuhang not table but tree diagram, kani siya, and kani is, di ba mo ni siya ang naka-indicate sa imuhang, these are the ones that relate to your B or bad parts. And then, ang kani siyang duha is to your, ang first o third kay sa good parts, ang second o fourth kay sa imuhang bad parts. So, the first three, or the first and third probability is the probability of your good parts, while the second and fourth is the probability of your bad parts. So, mo na siya. Or nakuha na siya gamit ani. So, with that, let's get the probability. So, your joint probability divided by the sum. So, that is here 0. And the other one is 57.38. So, if mo tanaw ta diri, balik ta ato. See? Same gyapon siya answer. 42.62% and 57.38. So, ayaw mo ka-intimidate, ani. Diba? This formula seems to be very intimidating. Kahit mo daghan kay siya letters. So, mura siya makalibog and mura siya libog and you seem like you don't want to solve it. But technically, if una-hunaon nimo kay igo ra gyud kang ang imuha rang yung buhaton, no, is kanirang sa part sa imuhang joint probabilities, which dali ra kay pagkuha kay multiply ra nimong duha, di ba? This column here is given. This column here is also given. Ang asa ra ka mo work on is this last two columns. So, the fourth column is simply multiply ra nimong second or third column. Now, sa posterior probabilities, ang answer nimo sa fourth column kay imo ring i-divide sa sum sa katong tanan nimo answer sa fourth column. So that is the posterior probability. So ana ra siya kadali, mura lang ni siya intimidating, pero intimidating because of how the formula looks, but if you really try to analyze it, kay balik-balik na siya or dali ra kay siya sabton kay tungod given na mostly ang information. So imuha na lang is ang pagpangita na lang on what information to use and how to use it. So mao lang gid ang imuhang pagdetermine. So as analysis or so kani siya mo naman natong solve dira. If we try to get the sum of the posterior probability, of course the sum would always be equal to 1. So, ano siya. Now, if we analyze, there is a 1.3% probability that the part came from supplier 1 is bad. So, kani siya. Kani atong analysis ani. Now, there is a 1.75 probability that the part came from supplier 2 is bad. And then the overall probability of finding a bad part from the combined shipments of two suppliers is 0.3. So, mo nang kani mo ang probability of the bad part. And then, again, kani, na naman na ato ang analysis a while ago. So, that is the Bayes theorem. Now, in addition, Bayes theorem is used extensively in decision analysis. So, the prior probabilities are often subjective estimates provided by a decision maker. Now, sample information is provided and posterior or given that there are new information, posterior probabilities are then computed for use in choosing the best decision. So, ano siya? An event and its complement are mutually exclusive. Again, take note of this. An event and its complement are mutually exclusive. Okay, of course, they share no sample points. So, event o yung complement is mutually exclusive. And their union is the entire sample space. So, if mangita daw ka sa union sa two events, is mo nang entire sample space. Mo nang nahitabo diri sa ang example sa Bayes theorem. So, thus, Bayes theorem is always applicable for computing posterior probabilities of an event and its complement. So, maunang inig-add ni mo ani, kay imuhang answer is always 1 because what you are trying to look at sa Bayes theorem is the probability sa event ug ang iyahang complement. Now, if you get the probability of the event and its complement, di ba, balik ta to sa pinakauna gid nato nga equation katong sa ato ang complement of an event, di ba? Their probability would always equal to 1. Mo nang diri sa imuhang Bayes theorem or the sum of your posterior probabilities would always be equal to 1. So that is the end of Bayes theorem.